Good morning, students. This is Elementary Statistics 1401, and today is June 22nd. Our plan is to wrap up 6.5. We're going to talk about a new topic, combination. We're going to do a couple of problems. So it'll be a short session. We are wrapping up. We spent almost 3 days on 6.5.5. However, it's a difficult concept, so bear with me. Okay, we're going to talk about this new idea called combination. What is a combination? Okay, and there's a nice formula that goes with combination, but that's okay. We're going to come back to come back to this formula over here in a second. Combination is a little different, let's say, from permutation. Let's say, let's say I have 5 people, okay? A, B, C, D, and E, okay? I am going to grab any two and send them to a conference, to a statistics conference. How many ways can I do it? Now, you do have to understand here, the order doesn't matter. If I choose A and then B, it's same as choosing B and then A. So let's answer that question. I have 5 students. 2 of them will go to a conference. How many ways can I do it? Well, I can do AB, AC, AD, AE. Okay. Then I can do BC, BD, BE. Then I can do CD, CE, CD, CE, and then I can do DE. I can send DE. So the pattern is you start with A, make sure A is there. A can be paired up with the remaining 4. Then all the possible ways A can go is done. You start with B. Now, and do the same thing. B can go with C, D, and E. They're unique combinations. So how many ways can I send 2 people from a group of 5 people to a conference if I don't care about the order? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is written. Your book writes it like this. I'm going to have to handwrite it. N combination R, and we are going to write it like this. You can read it that way. We're going to say C, N, comma, R. Okay. In this example, the first number 5 is 5 people. It's also read 5 choose N choose R, N combination R, both are considered acceptable. And this is how we write it. In our example, it was 5 choose R or 5 combination 2. And why? Because we have 5 people and we are sending 2 of them. All right. According to this formula, we are going to kind of describe this formula, why this formula makes sense in a second. Let's see if we got the right answer. According to this formula, it should be 5 factorial divided by 2 factorial times 5 minus 2, 3 factorial. Okay. Now, I can do it by hand, but I'm going to use the calculator. Okay. It's just going to save me a couple of seconds, right? So I hope it's same as the answer we got here. 5 factorial, 5 factorial divided by 2 factorial is 2, and 3 factorial is 3 times 2 times 1, which is 6, which is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it seems to work. So now we are going to give you some details why this formula is correct. Another way to remember this formula, another way, and you want to keep it handy. This is also true. I'm going to keep this example. So let me come back. This is also true. And that's going to help you a little bit with regard to understanding this problem. All right. All right. So the formula on top that's from your text is correct. Okay. Now, remember, guys, this n permutation r is simply n factorial divided by n minus r. So I can write that. So I'm going to show you why they are the same formula. Both are good. I don't need this. I won't write it like this. Remember from last class, n permutation r is n factorial divided by n minus r factorial. And don't forget the r factorial in our formula on the left-hand side. All right. Now, we didn't explain why this formula is true. Okay. I will try to explain it. It's a little hard. Okay. It's subtle and a little difficult, but we'll try it anyway. So, guys, I am going to pretend. Let me write down my problem scenario. I do need this. I'm going to save them here. I may need it. I don't know if I do. So I have 5 people, and we're talking about combination. So that's done. I have 5 people, and I want to send two of these 5 people to a conference. I have 5 students, and 2 of them will be sent to a conference. How many ways can this be done? All right. So guys, I'm going to get rid of this because I have the formula here, right? I have it here. I need the room. So I have 5 students and 2 of them will be sent to a conference. How many ways can this be done? Hmm, that's a little strange. Anyway, let me make it a little smaller. So this is my main problem. Okay, guys? This formula can be here. So for 1 second, guys, pretend I'm trying to prove to you why this formula makes sense, okay? To be honest, I don't even need these. I'm going to erase it. I need the room. It's a hard concept, so bear with me. Suppose I have 5 people, 5 students, and 2 of them will be sent to a conference. Anyway, this is acting a little funny today, but we'll make do. All right, guys, I have 5 people, 5 students. 2 of them will be sent to a conference. How many ways can this be done? Let's pretend that the order matters. So I have 5 students. I'm going to have 2 chairs, and I want to put them on the 2 chairs, 2 of the 5 students. I want to photograph them. Then you would say, well, that's easy. We did it last time. You would say, oh, that's how many ways can this be done? Well, permutation of 5 comma 2. Okay, 5 people, 2 chairs, photographs, order matters. Now I am going to say, guys, I'm going to say, look, the 2 people sitting on the chair, order doesn't matter. So how many ways can 2 people sit on 2 chairs? The answer is 2 factorial. So you're going to divide it by 2 factorial because the order doesn't matter. You're counting it too many times. When you're doing permutation, you're counting it too many times. Now take a look. We have this nice formula. Permutation of 5 comma 2 is 5 factorial divided by 5 minus 2, 3 factorial. And don't forget the 2 factorial we have to divide by because the order really doesn't matter. For 1 second, we pretended the order mattered. order mattered, and that's why we got the top. But since the order doesn't matter, the total number of ways two people can sit on two chairs is 2 factorial. You divide it by 2 factorial. It actually works for 3 students, 4 students, 5 students. It's a little hard, a little subtle. It takes a little bit of time to get this, but you want to be familiar with both version of the problem formula. Okay, you can write it down somewhere. Your book talks about this, but you also want to see why this is true. So basically, we're going to do some combination problems. All right. And we're going to use this formula, which is not that difficult, except for they're not going to tell you explicitly if order matters or if order does not matter. You have to figure it out from the context. And that's what makes combination permutation problems a little difficult. When I do the problems, I'm going to tell you why order matters, why order doesn't matter, all those things. All right. I'm going to save this here. I don't need this anymore. So this is my combination formula. And let's see what our book has. Excuse me, we're still working on 5.5. We'll do that one. Here's a nice problem. Let's grab this from your book. It's an example. Roger, Ken, Tom, Jay are going to play golf. They randomly select teams of 2 players. Okay. List all possible team combinations. All right. So that's kind of similar to what we did 2 seconds ago, but we had 5 people. Now we have 4. So I'm going to say, okay, I'm going to, if you don't mind, I'm going to write R for Roger, K for Ken, T for Tom, and J for J. 4 people. So you want to see how many ways can they be paired up? Start with the first person. Okay. What do we get? R. R can play with K. R can play with T. R can play with J. All right, the first cluster. Now, all the possible ways R can play with another person is there. Then grab the second person, K. K can play with T. K can play with J. All right. Then T and J. The last pair is T and J. So how many ways they can be paired up? I'm getting 6. All right. Let's use this formula for choose 2. Let's see what we get. It's red for choose 2, for combination 2, as I said earlier. So I'm just going to write 4, comma 2. What do we get? 4 factorial divided by 2 factorial. And then 4 minus 2 is also 2. So it's 2 factorial. Now, this is easy enough. I don't believe I need my calculator. And I hope my answer is going to be 6. 4 factorial is 4 times 3 times 2 times 1. And 2 factorial is 2 times 1, that's 2. 2 times 1, that's 2. And what do we get? 2 factorial, 2 times 2 is 4. And this I can write, replace it with 4. Then I can cancel this 4 with the other 4. And what am I left with? 3 times 2 times 1, which is 6. So at least we got it right. We don't have to check our answer. This is correct. But beware, the question says list all the combinations. So we did list them right here. So you kind of have to do it this way. Okay? Let's do one more problem from your book. Actually, a couple more, not just one. Okay. How many different, okay. Again, guys, now we know that these are combination problems. We kind of have an idea because that's what we're talking about. But make sure you understand what's going on because on the exam, these will be random questions, right? Let's read it. How many different simple random samples of size 4 can be obtained? When you have a random sample of size 4 from a population of 12, let's say you have 20 students, not 12, 20, and you're going to grab 4, a sample of 4. Let's say you're going to test them, see if they can do certain problems or if you want to interview them for something, right? You don't care about the order. As long as those 4 people are there, the order in which they were selected does not affect anything. So you're going to say, well, since the order doesn't matter, it has to be C, comma, 20. And that turns out to be 20 factorial divided by 4 factorial. And 20 minus 4 is 16 factorial. Now you would appreciate the notation. Okay. Now, some calculators have this combination key, but if you don't worry. You don't need to go ahead and buy a fancy calculator. You can just use this calculator that I'm using, Desmos. So I'm going to say 20 factorial divided by, in parentheses, 4 factorial times 16 factorial. Okay, I'm getting this log number 4,845. Let's bring this guy here. I'll tell you one more thing about this calculator, which I didn't realize. All right, so this is there. Your calculator has this key, so which is nice. Let's see how this calculator uses that key. I've never used it. Okay, cool. So they're saying your n is 20, comma, 4. And we got the same answer. So if you use Desmos, you have this key. N choose R, N combination R can be entered this way, as you can see, and we're getting the same answer. So we didn't quite mess up. So here it is. I think we are ready for some problems from your book. Actually, we are kind of done, but we have a little bit of time. I'm going to open your text, okay, and grab a couple of combination problems. All right, let's find out. 5.5. See if I can find something interesting. And I'll tell you why I think order doesn't matter, okay? So while we work on it, I don't do 5.6, okay? We'll jump to 5.7 next class. Just be aware of that. Counting techniques. I'm going to do a couple of problems, clothing options. Let's see. So take a look at this one. How many different simple random samples of size 5 can be obtained from a population of 50? So we did one like this. Okay, let's do this. And there's nothing to it, you'll see. Well, I am going to argue this is clearly a question that involves combination because we're talking about random samples. The order doesn't matter. And this is going to be 50 people. And you're going to get a random sample of 5. So it's 50, comma 5. And you don't need this anymore. But let's do it. 50 divided by 5 factorial. 50 minus 5 is 45. And let's see what we get. I'm going to just use the combination key. 50 cubed 5. It's a large number. Now, depending on your book, if your book wants you to find the number, fine. If your book says leave it like this, with C, totally fine with me, or fine with the book. Your book grades, your MATLAB is graded by the computer. So whatever they ask you to do, you will do, and you should be able to do both. All right. Another thing, now it seems too easy because you know I'm picking up combination problems, but make sure you kind of know the distinction between permutation and combination. Let's grab a couple more. Okay, let's try this. Let's try this. I'm hoping it's a combination problem, but we'll find out. I haven't read it um, carefully. Let's read it. If it's not a combination problem, I'll certainly let you know. In the US Senate, there are 21 members on the Committee on Banking. So there is a committee, there are 21 people. Banking, housing, and urban affairs. Sure. There are 21 people we're talking about. 9 of these 21 members are selected to be on the subcommittee on economic policy. How many different committee structures are possible? Now, in a committee, the order doesn't matter. If they said, I have a committee and there is a president, there is a vice president, there is a secretary, yes, the order will play a role. But here the order doesn't matter. I have 21 people and I'm going to find out 9 people without worrying about the order. So it's going to be 21, choose 9. And of course, you can directly use your calculator, but I'm going to say 21, 9. 21 minus 9 is what, guys? 12. All right, and let's see what that turns out to be. I'm just going to do 21 twos, 9. And let's go here. And that's again large number. These are large numbers. Done. So I don't have much to add, but let's talk a little bit about a few things. Again, I try to mention it on a regular basis. You can come and meet with me during my office hours. If you want to schedule an appointment, we'll be happy to do that via email. If you want to give me a problem that you want me to work on, that can also be done. If I get an email today saying, could you do number 5? Please mention your course. Give me a screen capture, give me the number, give me those 3 details. Course, ideally a screen capture, a number and section. I'll be happy to do it and practice some of these. I'm just trying to caution you a little bit. I did counting principle first, and then we did permutation. Permutation is a special case of counting principle. Really, that's all there is to it. Now, combination is very different, really, and combination is related to permutation, but it's not a type of permutation. Combination and permutation are very different. They're related, okay, but they're different. Again, a little bit of summary. In permutation, order matters. In combination, order does not matter. Permutation is generally about arrangement. You cannot repeat. So let's write down some of those points, okay? A little bit of summary, okay, about permutation and combination. Okay, permutation, order matters. Repetition is not allowed. Okay, order matters. Is not allowed. And permutation is really a special case of counting principle. Okay, it's something most of you won't need to know that, but it doesn't hurt. It is about arranging things. It's about arrangement. It is about generally arrangement. That's why repetition is not allowed. If you're arranging 5 books in a row, you can't take the first book, put it in 5 places. You cannot. This is about permutation. All right. So let's say something about combination here. Order doesn't matter. Order doesn't matter. Okay. Order doesn't matter. A couple of things. Combinations in this problem, keywords are not the best thing you can rely on. Okay, I'll give you an example. Combination lock does not involve combination. But, but when you're talking about committees, when you're talking about sample, you know that order doesn't matter. So keep those words. When you see those words, you want to reanalyze and ask yourself, does order really matter here? And hopefully, when it's committee, when it's a group of people going to a museum or a conference, generally you don't care about the order. As long as a certain group of people are going, you're all set. That's all you care about, right? So keep these ideas straight. Try all the problems from 5.5. You should be able to do them. And again, if you run into problems, please let me know. And we'll wrap up our lesson here today. Thank you, guys. I'll see you next week.